Now, one of the things with these timers, they're functions. And you can put more functions after each other. You can stack your functions. But your contacts all have to be over here on the left. If you need any contacts after the function, you have to run them off of your output coil. You cannot put any contacts from the right of the function to the left of the coil. No contacts in there at all. Okay?
Why?
That's the way Proficy's set up. All your contacts have to go over here on the left. Okay? But I can sit there and say I wanted a timer. I wanted a long seconds timer plus some microseconds. Okay? Well, not microseconds, milliseconds, excuse me. So I'm going to come over here. Timer, thousands. You see that? I got another timer in there. Okay? Now I'm going to come over here, I'm going to drag timer 2 onto it. Okay? And I'm going to put 100. Okay? So what is my total time here? Okay? The one on the left over here, 8.5 seconds, right?
Yeah.
Thousands, I've got 100 thousandths. So that's 0.1 seconds. My total on delay time will be 8.6 seconds. Okay? You can cascade timers like that.
So they just add together.
Add them together. Okay? So what happens? This output will be off. When all these outputs will be off. Turn the input on. 8.5 seconds later, that output will turn on. This will start counting. 100 milliseconds after that counts, the output will turn on. Okay? So I'm going to put some bigger number in there so that you can watch it count. And if I did 3,000, that's 3 seconds, right? So let me use 8,000. Well, 8,500. So what do I have here now? I've got 8.5 seconds here, 8.5 seconds here, for a total of 19 seconds. Now, someone will say, well, why didn't I just put 190 over there and be done with it? Right?
Yeah.
Well, if you have the needs to have a long time plus some precision time, you can cascade these this way. Or what happens if you have a count? You need to do a timer longer than what 32,767 will allow you. What is that? That's 3,200 seconds, right? What if you have a time that's longer than 3,200 seconds? Well, you can start cascading these timers and build up whatever time you need. Okay? So, we set this up. Okay? I'm going to stop it. Download it. Okay, downloading, outputs enabled. Both timers are set to 0, right? Okay, output is off, correct? Okay, here we go. We're going to force this on. Okay, you can see timer 1 counting. Timer 2 is not counting yet, is it? Okay, as soon as it gets to 85, now timer 2 starts counting. Okay? And as soon as it gets to 8,500, your output is on. Now, you notice the timer is still counting. Right? They're still timing up, aren't they?
Why is output 2 on?
Pardon me?
Why is output 2 on?
Output 2 is on because my input to the timer is on, and it's an off delay timer. See, input 1 and input 1 are the same inputs to both timers.
So why is it counting though? Why is it counting?
It's not counting because this is an off delay timer. It won't start counting until we turn this off. Okay? Now, you notice that this timer over here got to what number? 32,767, and it stopped. This one will keep counting until it gets to 32,767. Now, what's really nice about this is if you need to do some math of how long it's been since your output turned on, as long as when it's within the range of this timing here, okay, you can sit there and calculate how many seconds or how many thousandths of a second it's been since your output turned on. Okay, it's still counting, and you can use that value because CV is still changing. All right. Now, if I turn it off, okay, output goes off, both timers reset to 0. Now this off delay timer is counting. When it gets to 100, the output over there will turn off also.
Okay.
There you go, it's off.
Is there a way you can, I can say, pause the timer when it's off so you can do the calculations? Because I noticed once you turned it off, those 2 timers in the top, they went back to 0. So now I can't go back.
It can't go back and do it. No, you wouldn't pause it. You just do your calculations on the fly.
Just on the, okay.
Do a snapshot, do your calculations. And, okay, the output came on 3 seconds ago. Good. Now turn on a new output. Okay? So you can use your timer and the CV to trigger other events. Okay? Now, if you have combinational logic, other timers, other PLCs have a timing in process flag. Okay? Meaning it's counting the time delay. The time where it's in the delay, meaning the input is enabled but the output is not on. It has a little output that says that. You can create that. I'll show you what I mean. Okay? I'm going to come over here. I'm going to delete the off delay also. Okay? I'm going to come over here and put a contact. Label that input 1. Another contact over here. Output 1. Okay. Now if you look at this, if input 1 is energized and output 1 is not energized, I'm in a timing delay, aren't I? Is that the startup timing during that period? Okay. Input 1 is energized. Until my timing completes, what's the status going to be of output number 1 up there? It's going to be off, right? Boy, such resounding assurance from all of you. Okay? So, input 1 turns on. What happens immediately to output 1? Does it stay off or does it turn on? Stays off until my timers expire, right? Timers count up, the output will turn on. That period is my delay window, right? That's my on delay period. If input 1 is on and output 1 is off, that's my delay window, isn't it?
So you're using existing timers to replicate that delay.
I'm using combinational logic here to create an output that will indicate the delay period. Okay? So as soon as the delay period finishes, right, and this output 1 turns on, those contacts will open up, won't they? All right? So let's watch what happens here. I'm also going to change the time here so we don't need to wait. I'll put in here 20 and 30. That's 5 seconds, right? Oh, no, it's not.
No.
That's thousandths. Okay? All right, you ready? Let's download this thing again. Okay, we're almost downloaded. There we go. Now, so look over there, our output 1 is off, right?
Right.
So we've got power flow through these contacts. Our input is off, so we don't have power flow through there. So we're not in our timing delay right now, are we?
No.
Okay? All right, there we go. Turn the input 1 on. Okay, our output 4 is on, saying we're in our timing delay. Watch 4 and 1. They toggled, didn't they? All right? So as soon as I turn the input on, output 4 turned on, we are in our delay period. 5 seconds later, it turned off, and our output turned on. Output 1 turned on. So let's watch that again. Go ahead and turn it off. Okay? Both outputs are off now, right? Now, go ahead. Turn it on. We're timing. Our output 4 is on, saying when our timing. And output 1 turns on, output 4 turns off.
So that would be for like an indicator light that we're in a delay period?
Pardon me?
So that would be an indicator
That
light.
at the end of the delay period.
Alright.
Correct. Now you can do the same thing with the off delay, saying this is my off delay. Okay? In some, I forget which lab it is, you're going to need to use the off delay indicator. I think both the timing labs and your on delay indicator. You'll have to put a light on that says when you are in your timing delay. Okay? Any other questions? Okay.